Topic 4, statistics and probabilities. Okay, so for the events A and B, probability of A is 0.6, probability of B is 0.8, and the union is 0.1. Find the intersection and find A union B not. Okay, so the first part, we do have a formula for this. We have a formula that always applies. Some formulas don't apply. Mutually exclusive only works when you have mutually exclusive things. Independent only works when you have independent things. But the formula that always works no matter what case, I mean, it's always applicable. It doesn't always help you, is this one. Probability of A union B equals probability of A plus probability of B minus probability of A intersection B. I'm going to have space there. So this formula always works if it's applicable. So with that in mind, I could substitute it in. I know this is 1. I know A is 0.6. I know B is 0.48. And I don't know what that is. That's what I'm looking for. So now it's a basic math problem. 1 equals 1.4 minus x. Negative 0.4 equals negative x. So x equals 0.4, which is probability of A intersection B. That's probably, there we go. So 0.4. And now, what's the probability of A, not A, union, not B? Now, honestly, right now I'm looking at it, I'm like, I don't know. Let's draw this picture so I can figure out what's going on here. So we have this. This is my A, this is my B. Probability of, I know the intersection that we just found is 0.4. The whole thing is 1. So if the whole thing is 1, my union is 1. That means that outside is nothing. Because this intersection is 1. And anytime you make a graph with decimals, the whole thing is 1. A is 0.6. All of A is 0.6. But the middle is 0.4. So this is 0.2. And the same thing here. All of B is 0.8. But the middle is 0.4. So this is 0.4. Okay. And I want the union of not A and not B. Okay. So union, not A. I'm going to do some shades here. Not A is all of this. So that's not A. Everything that's not in A. So like it's missing 0.2 and 0.4. That's not in A. The union of not in B. Well, what's not in B? Let me do that in purple. So not in B is everything that doesn't touch B. That'll also go vertically for this one. So that's all that. So remember the union. So anything that has a color is what I want. So the only thing that's not in this is a little white there. So my answer here is going to be, it's basically 1 minus 0.4, which is 0.6. Right, the only thing that wasn't colored, the only thing that's not included is the 0.4 in the middle. So I think I was supposed to remember that this is the same thing as saying probability of A intersection B not. Right, so if you know what the intersection B is, which we just found, the complement of that is what this is. I forgot, I just drew a picture and solved it either way. So that's how you do it. Okay, next one. Survey of 200 people, 90 of whom are female. Also found that 60 people are unemployed. So, and including 20 males. So in the survey of 200 people, 90 of whom are female. So here's females. I know that 90 of them are female, which makes that this is 110. It was found that 60 people were unemployed, including 20 males. So unemployed is 60, including 20 males. So just with that, I want to fill out the rest of it. Well, if this is 110 and that's 20, that makes this 90. Right, and this is 20 and 60, that makes this 40. That's a lot of females. 990 minus 40 gets me 50 here. And then either way you want to do it, add these across or subtract these two, you should get 140 here. So first fill out the table. Next question. If a person selected at random from a group of 200 people, found the probability that person is an unemployed female. So when you want probabilities, just generally want over total. My total is 200 people. I want an unemployed female for some reason. Okay, so unemployed and female is 440. So and there you go. You don't have to reduce it. You can reduce it if you want to. It's 4 over 20, which is 0.2. But you're allowed to leave as a fraction. You're done. A male, given that the person is employed. So this changes, this part right here, the given that, changes everything. So given that the person's employed, you're only looking at the employed people. You know it's employed, so the only thing you're looking at are these people. So that's it. That's all I care about. You know they're employed, so my total now, still want over total, my total now is 140 because I know it's unemployed. Employed. I want a male. So how many males are there? 90 out of 140. So there we go. The following Venn diagram shows a sample space U and event A and B. So my union is 36. So the whole universe here is 36 things. The number of A is 11. So keep in mind with that, it's not, this portion's not 11, all of A is 11. So I like to write it up here, like this is 11. And the same thing with B. B is this whole circle, not this portion, the whole circle. So that's 6. And then here we go again. A union B naught is 21. So we're going to have to deal with that in a second. On the diagram, shade A union B naught. Okay, so remember what that saying is what's not in A union B. So the little prime means like the opposite. So first let's talk about what's A union B. Now that we should know. A union B is 2 circles. So that's A union B is, these 2 circles. So I want not that. So I just want the outside. So that's all that is saying. So I want the outside. So we're going to shade the outside. Right, because A union B are the 2 circles, and I want not that. I want the prime of that. My shading could be better, but there we go. Something to that effect. And again, I know that's 21, so that's a big deal. Well, this outside is 21. Now that I figured out what A union B is, that's 21. So shaded it, put all my stuff there. They want me to find the number in A intersection B. Okay, so let's do that. B1. Now remember what I said before, there's one formula that always works in these contexts. No matter what, it always applies. It might not be helpful, but you are allowed to use it, and that is A union B. In this case, we're talking about numbers, so we'll put N here. It works for N or P, doesn't matter. You're supposed to use P when it's probability, you're supposed to use N when it's numbers. So number in A plus the number in B minus the number in the intersection. Now, there's one thing we're going to talk about here, but in general, this is what we're doing. Actually, no, we're good. We don't do anything else. A union B, so normally the way you find A union B is you do this guy minus the outside here. Like, that's how you find this. It's the universe minus the outside. That gets you this guy. So this is always the universe minus the outside. The neither is the word for that. Right, neither in A or B. So that's how you find this. So it'll be 36 minus 21. In this case, we actually need to do that because they already told me that A union B, like not that, is 21. So that means that these 2 circles would be 36 minus 21, which is 15. Right, it's not 21. 21 is not this. It's the opposite of this. So 36 minus 21 gets me what I want. And then these 2 things they told me. The number in A is 11. The number in B is 6. And I'm looking for this. So I get 15 equals 17 minus x. You can do the math real quick, right? Add the x, subtract the 15, x equals 2. So that is my number in A intersection B. So this is 2. Now look at the next question. A probability of A intersection B, right? There's a slight difference here. Number is just how many things are actually in there, which we figured out right now is 2. I'm going to rewrite that for the key. So we figured out that is 2. Probability is 1 over total. So my want is 2, because that's what the intersection is, and the total is 36. And again, you don't need to reduce it, you're good. Explain why events in A or B are not mutually exclusive. So remember, mutually exclusive means that the intersection equals 0. So all you gotta say here is, well, probability of A, intersection probability of B does not equal 0. And there you go, it's not mutually exclusive. Or you can say the number, it doesn't matter. A intersection B is not equal to 0, it's probably the key there. Either way, it's true, though. That's why. Okay, next one. The following diagram shows a circle divided into 3 sectors, A, B, and C. The angles at the center of the circles are 90, 120, 150. Sectors A, B are shown. So there's 90, 120, 150. The arrow is spun. It cannot land on lines between the sectors, so it can't land in the middle. Okay, and these are arrow lands Sector A, Sector B, Sector C in the shaded region. Find the probability that it lands in Sector B. Well, B is 120 and the full circle is 360, so it's still the same idea. It's want over total, and in this case, my want is 120 and my total is 360. So I get a 1 out of 3 shot. If I'm going to reduce it, 1 out of 3. Which in this case, since I'm probably going to have to use more stuff, I'm going to reduce it. I mean, you don't have to reduce it. You're allowed to leave it the way it is. But since I think I'm going to have to use it later, I'm going to reduce it for my own sake. Probability shaded region, same idea. 1 over total. Well, how much is shaded? 90 plus 120, so 210. Over 360. So that's going to say 21 over 360. Divide by 3 to make it a little nicer for myself. 7 over 12. And the only reason I'm doing that is because I think I'm going to have to use these values later. Okay, and then the last one, the given that. That's the fun one. That's in your formula sheet. In the formula sheets, they tell you probability of A. I believe maybe it's B given A. B given A is probability of A intersection B over the second one, probability of A. So that's from the formula sheet. That looks terrible. That just looks terrible. From the formula sheet, they give us probability of B given A equals probability of A intersection B over probability of A. It's always over the second one. The given that is what it's over. So it's an intersection over the second one, basically. Given that part. So for us, when we're doing C, it's probability of A given S. So we're going to do the same formula. Probability of A intersection S over probability of S. Now we figure out what the probability of S is 7 over 12. We have to figure out this one. And usually when we do a given that portion, this is the hard part. What's A intersection S? So we start thinking about it logically. A is odds land in A, and S is a shaded region. So where do they intersect? Where do these two things intersect? They intersect at probability of A. Right? If I'm saying I want this intersection with just this, well, it's just that. Like, that's the overlap. Like, right, probability of A is this portion, and probability of S is this portion. The intersection is just going to be this guy. It's just that guy. So that's just probability of A. So now we just got to do probability of A over probability of S, which is going to be probability of A is 1 over total, so 90 over 360. And so maybe I didn't need to simplify. It's easier if I don't simplify. 90 over 360, and probability of S is 210 over 360. And remember, that's just a divide sign, so we're going to rewrite it. So 90 over 360 times 360, right? Multiply the reciprocal over 210. These cancel, so you just get 90 over 210. Which again, if you want, you can reduce it, you don't have to. So that's C, given that. Next one, the population below is listed in ascending order. So this is in ascending order. The median of the population is 9.5. The upper quartile is 13. Write down the value of R and S. Okay, so how many things we have here? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 items. The median will be the middle number. So there's going to be, since even there's no middle number, it's going to be between these two. So I know that the way you find the median is, if there's no middle number, is you add them up, n plus r divided by 2 should equal 9.5. That's how you find the median. Again, if there's only one term, it's just that. It's a median, but there's two terms. If it's even like this, you add up the middle two terms and divide by 2. So this is my formula, times it by 2. You get 9 plus r equals 18 to 19. And then subtract 9. R equals 10. So R is 10. So now I know that this is going to be 10 right there. The upper quartile is 13. So upper quartile is when you look at the top half. So it's from here to here. So let me write this again. So it's 10, 10, S, 13, 13, T. This is the upper quartile. It's the top half, I should say. So it means Q3 is going to be halfway between these two. That's Q3. Well, so S plus 13 divided by 2 equals 13. Well, obviously S is 13. You can do the math, but it's going to be 13. Right, so it's a general idea. Like you split, the median would split like halfway between these two, and the upper quartile split halfway between these two. So since it's halfway between those two, not following along, you just add them up, divide by 2, add them up, divide by 2. So done. The mean of the population is 10. Find the value of t. So the mean means add them all up, sum, divide by the number of items, equals 10. So in this case, we're going to add them all up. I'm going to do 5 plus 6 plus 7 plus 7 plus 9 plus 9 plus r, which I know is 10, plus 10 plus s, which I know is 13, plus 13 plus 13 plus t, all divided by, we counted how many items we had, right? I had 12 items, and that equals 10. So I can do a little math here. Let's put my calculator. So 5 plus 6 plus 7 plus 7 plus 9 plus 9 plus 10 plus 10 plus 13, 13, 13, so 39, but let's do 13, 13, 13. So 102. As long as I didn't mess anything up, it should be 102 plus t over 12 equals 10. So then we multiply both sides by 10, 12. So 102 plus t equals 120 minus 102. So t equals 18. Now, as long as I didn't mess anything up, that should be right. It does fit. Like 18 would be the farthest right there, so that makes sense. So as long as I didn't mess up my putting that in a calculator, that looks like the right answer. Next one. In a school with 225 girls, each student is tested to see how many sit-ups they could do. I would not be able to do a lot. She can do it, so she can do it in 1 minute. The results are given in the table below. So these are the number of sit-ups. This is the number of students. This is the cumulative number of students. And you notice there's some missing things there. So we have to find the missing things. So remember the way the cumulative works? It's like the running total. So if I have 11, so I have 11 students, and then, so that's my running total now. It's like, this is kind of like your running total. So I have 11. So my total is 11. You add 21 to that. 21 plus 11 equals 32. So this is show that's 21 plus 11, right? And then to get to the next line, P, you're adding 33 to that. So this guy's going to be 33 plus 21 plus 11, which is also just saying 33 plus 32, which equals 65. So P equals 65. Right, and then 65 plus Q equals 99. So that's what's going on here. To find this one, you're going 65, my running total, plus my value of Q equals my new running total. So subtract 65. Q equals 34. So like that. And then again, if you want to double check your work, 99 plus 18 equals this, 117 plus 8 equals that. So that's how it goes here. So 65 would be 32 plus 31 equals 65. I like that better. Let me change this. There we go. So that plus that equals that. Find the median number of sit-ups. Okay, so we have 125 total. So it's, the way you find the median number in this case, it's 125 plus 1 divided by 2, which is 126 divided by 2, which is 63 term. So it's not 63, it's that term. Where does 63 fall? So look here, right? We have this. That's what we use the running total for. So at 11, we have our number says 15. At 32, my number says to 16. At 65, my number says to 17. So 63rd term would be between 32 and 65. It's between these two, so it's 17 sit-ups. Now remember, the median has to be from this value here. So this is the n plus 1 divided by 2 thing. This helps you figure out what term it is. So you go total number of people you have, add 1 divided by 2. That tells you what person is the median. And that's the 63rd person. 63rd person falls between these two values, so that means they're doing 17 sit-ups. Find the mean number of sit-ups. So that is in your formula sheet. That is the sum of x times f over the total n. So what you're supposed to do is multiply this by the frequency. So it's like 15 times 11 plus 16 times 21 plus 17 times 33 plus 18 times 34, I believe that's what that value we found, plus 19 times 18, plus 20 times 8, divided by 125. So that's one way to do it. You could also do L1, L2 in your calculator and do it that way. So you can do it this way, or L1, L2, one variable stats. So let's do the L1, L2 to show you how to do that. So edit. I get to delete all these values here, so I'm going to clear. That's from when I did trig a second ago. I'm going to put these in, so 15, 16, there's not that much, so you could watch me do it. 17, 18, I usually put these off camera. This is me typing stuff in, because it's so much fun. Okay, so that's not that bad. Took them in. 11, 21, 33, 34, some fit kids, 18, and 8. Okay, all typed in there. So I'm going to quit. I'm going to go to stats. Calculate, we're going to do one variable stats. In IB, we only ever use one variable stats. You don't do two variable stats unless you're like advanced stats stuff. One, frequency list. So you got to watch out. Sometimes you do this blank, sometimes you fill it in. This time, this is the frequency. These are how many times these people do this. So there should be a frequency list here. So L2. That's why we typed in an L2. So L1 and L2. And then we hit calculate. And then there's our mean, 17.48. So this would be 17.48. 08. 3 sig fig, 17.4. So there we go. Anything else that we could have done with that? The median number of sit-ups? Yeah, so they also told us that if you wanted to do that with a calculator. I was trying to show you how to do it by hand, but the calculator, you also do the same thing. So 17. Okay, moving on. Ooh, tree diagrams. These are like my favorite things in the world. So we have a student at Ivy World College. Probably that the student is woken up by his alarm clock is 7/8. So probably they're woken up is 7/8. If he is woken up by his alarm clock, the probability that he will be late for school is 1/4. So you have late, not late, and woken up. So like already this I know. Probably he's woken up is 7/8. So that means not woken up is 1/8, right? Anytime you do a line like this, it has to be 1. So if that's 7/8, it's 1/8. If he's woken up by his alarm clock, if we go this way, the probability that he's late is 1/4. So this is 1/4, which makes this 3/4. So again, each line, like each partition like that, should equal 1. If he is not woken up by his alarm clock, that's this guy, the probability that he will be late for school is 3/5. So if he's not woken up, then he's going to be late 3/5 of the time, which makes this 2/5 of the time. Because right, again, these should equal 1. Okay. W be the event he's woken up by his alarm clock, L he's late. Okay, got all that. Fill out the tree diagram, did that already. Calculate the probability that he would be late for school. So late, just how do you get late? So there's two ways to get late, right? You could be woken up and late, and you could be not woken up by alarm clock and late. So it's those two values. So this is going to be WL plus, anytime you add another string, you add them together. Not W and L. WL is 7/8 times 1/4 plus not W, which is 1/8 times L, which is 3/5. So I get 7/32 plus 3/40. Should I just put my calculator, I guess? Because I don't want to do that. I don't want to add. Figure out what that is. 32 plus 3/40. And we get approximately 2.9375. I might just put a fraction, math fraction. Yeah, it's 47 over 160. Yeah, not nice numbers. I don't like it. But anyway, that's the answer. Given that Tusami is late for school, Tumisani, what is the probability that he is woken by his alarm clock? So this is a given that. Given that he's late for school. So you have to know how to write this down. So probably given that he's late. Right, so the given that's the line. That's the given that line. So we know he's late. So given that he's late, what is the probability that he was woken up by his alarm clock? So we want woken up given that he's late. So we have to use a formula. So remember the formula is from our formula sheet. It's woken intersection late over probability of late. Now this is classic IB. We already figured out the late. We did that earlier. That's 47 over 160 over this decimal. How do you find Wilkin and late? Well, that's actually easy. It's just a line here. Wilkin and late. It's just that guy. This is just 7/8 times, because it's saying 1/4. So I get, what do I get? 7 over 32 over 47 over 160. Honestly, I probably just put it on a calculator. That looks ugly. Usually they're not as bad as this. They're usually pretty chill with it and stuff that cancels out nicely. But in this case, we're just going to do this divided by what I got up there. And then we get that. Let's make it a fraction for fun. We get 35 over 47. So we get 35 over 47. There we go. That's how you do it given that problem. Next, another Venn diagram. Consider the vents A and B where probability of A is 0.5, probability of B is 0.7, and the intersection is 0.3. So, intersection is 0.3 is the key. This is 0.3. Now, you gotta watch out. Again, 0.5 is not P. It's the whole circle. So, all of this is 0.5. And same thing here, probability of B is the whole circle is 0.7. Right, so it's not these portions, it's the whole circle. Write down the value of P. Well, P is this, so the whole circle is 0.5 minus 0.3, so this is 0.2. Q, same idea, right? All of this is 0.7, that's 0.3, so subtracting you get 0.4. I'll show the work right for you guys. So that's how you get those. And then R. So R is the outside. So the way you find R, so the whole circle is 1. And you want to subtract off the inside here. Right, so the whole circle is 1. We know this is 0.2, 0.3, and 0.4. So it's just 1 minus 0.2 plus 0.3 plus 0.4, which is 0.9. So 0.1. So this is 0.1. So that's how you get that, right? The whole circle, when we're talking about decimals, like probabilities, if they're doing probabilities and not numbers, then the whole box is 1. And you just got to figure out what everything else is, and then this is the outside. Hence, find the value of probability of A given not B. So with a Venn diagram, you could actually do it without doing the formula. You know it's not B. So here's B, you're not B. So you're like all the outside here. What's the probability that you're A? Well, A is this portion of it, so 0.2. So that's all it is. You're like, okay, you're not B, so it's one of these two, and then you want A, so 0.2. That's what that is. But also it's not that hard if you just use the formula. So this would be that equals A intersection not B over not B over not B. Okay. So A intersection not B. A intersection not B is 0.2. I guess when I said the answer before, it should have been 0.2 divided by 0.3. But anyway, without using the formula. That's why the formula is better. A intersection not B. So not B is not this guy. So it's all of this. It's not B. I want A intersection of that. So that's 0.2. And what's not B? Not B is the outside. These two, right? This is B. I want not B. So these put together is 0.3. Or another way to think about not B is, well, B is 0.7, right? So if you look at not B, that'll be 1 minus 0.7, which is B, so 0.3. So not B is 0.3, so you get 2/3. So like that. Hence or otherwise, show the events A and B are not independent. So they want you to show some things are independent or non-independent. Independent, the formula for that is probability of A times the probability of B equals the intersection A intersection B. So this is independent. If you know two things are independent, it's that. So to show they're not independent, we're going to show that this does not hold. So probability of A is 0.5 times probability of B, which is 0.7, does not equal probability of the intersection, which is 0.3. Right, because we get 0.35 does not equal 0.3. So, not independent. I'll put because probability of A times probability of B does not equal the probability of A intersection B. like that. Okay, I think this is the last question. And this is a cumulative frequency graph. Following cumulative frequency graph for a time, T minutes spent by 150 people in a particular day. So 150 is the max here. How many people spend less than 5 minutes at the store? So we have 5 minutes. Remember, less than you go down, more than you go up. So key here is use a graph. So 5 minutes. So here's 5. Follow the graph. And that goes across. So it's 50. Now the key here is it's less than. So 50 means you go down, so it's 50 people. If it was more than, it would be 50 to 150, be 100. Find the number of people who spend between 5 and 7 minutes. Well, we already have 5, so now let's do 7. Now we're going to do, after this, is subtract, so that's easy. So like that. Oh my. I don't think it goes nicely. I hate when it doesn't go nicely. So I'm going to say 92. That's going to be like a guess. It's an estimate. It might be a little bit wrong. But I'm going to say that 5 is 50, and this is 92. So 92 minus 50 would give me 42. I thought it was going to be nice, but it actually went a little past it. Find the median number of people in the store. So we'll do that in red. So the median number is half of it. So you have 150 people, divide that by 2. That's going to be 75. But remember, we're going to go 75 across and down. Right? So median is, you use this value, but you don't just use that answer. It's median times from the store. But my answer should be a time. So median is half of these guys, so it's 75. Go across and go down. I did not know it was going to be so ugly. Okay, so 75 is around here. It's going to be an estimate. That's not what I wanted to draw. Around there, and then we're going to go down. So again, this is going to be an estimate because it's not perfect. So it looks like, what, 6.2-ish? I didn't realize it would be such a bad. I would have made it a bigger graph, so it would be easier to do. So let's say 6.2. Okay, next one. Convincing a graph showing heights of 150 girls at school, 120 girls at school. Write down the median. So let's do the median again. So now, keep in mind, it's 120. They're trying to mess with you, this 130 thing. I don't need this at all. This is all like just there to mess with you. You just need the 120. So half of that would be 60. And again, use the graph across and down. This one looks a lot easier already. So we're going to go 60, and we're going to go across and down. So that should be 165. Like that. Now, the next one, find the interquartile range. So that's Q3 minus Q1. Remember, Q3 is the median of the top half. So between 120 and 160, halfway, add them up, divide by 2 if you want. That's going to be 90. So this is Q3. This is a median right here. So we'll go across. Oh, I love this graph so much better already. It's so much nicer than the last one. So 170. Q3, same idea. Halfway between 60 and 0 is 30. So that's my Q1, I should say. Across. Oh, I love this graph. 160. So my IQR is just 10. So there we go. Last one. Given that 60% of the girls are taller than 8 centimeters, find the value of A. So there's 150 girls, 220 girls, sorry. Times it by 0.6. And if you do that, I should know that. But I'm going to multiply just in case. You get 72. Now the key thing with this is it's taller than. So when it's taller, it means you go from the top. Right? If it was shorter, then you go from the bottom. So 72 from the top. So 120 minus 72. Which is what, 48? Yeah. So I should be at 48. So around here. Remember when I said I love this one? I almost love it too much. This side doesn't. So it's 48. So 72 from the top, right? Because it's the top. 60% of girls are taller than that. So like that. You go across. Still works out pretty nicely. I think it's this value right here. Which I think it's 63 might be my guess. So I get 163 centimeters. So the idea here is, right, is 60% of girls are taller than that. So if you go to 63, 163, go up and across, 60% of them should be above here, which is what it is. And then 40% will be down here. So if it says taller, you go from the top. If it says lower, you go from the bottom. That's the general idea. So I did 120 times 60, I got 72. So 72 people are taller than it. But since it says taller, you have to go from the top. So 72 down, across, and down. So I get that. And that's the video.